let's see more dividing radicals. So the first two examples, I just review, because we have done this before. We have one radical in the numerator, we have one radical in the denominator. Right? Usually we want the denominator to be a rational number. So we want to multiply radical 5, divides itself. Basically, we multiply by 1, because an expression multiplied by 1 doesn't change its value. Then the denominator will have radical 5 times itself, that becomes 5. So the denominator becomes 4 times 5. And the numerator is square root of 4, we know. Square root of 4 is 2. Right? So 2 simplifies 4 into 2. So in the end, you just get 1/10. So the answer for 5 is 1/10. Now let's say 6. Let's use the red color. 6, we want to multiply by 1 again. Guess what this one is? Yes. Square root of 5 divides itself, because we want to change square root of 5 from an irrational number to be a rational number. Then the numerator we have 4 radical 10, because 2 is a prime, 5 is a prime. What do we do with them? We just multiply them. And then the denominator will have 3 times 5, which is 15. Right? Because square root of 5 times square root of 5, that's 5. Square root of 5 itself means when you square it, it becomes 5. Now let's see 7. 7, what's the difference now? We have negative 3, we have negative 12, we have 2 terms in the numerator. Right? But we still have 1 term in the denominator. So what do? We multiply by square root of 17. Because we want to get rid of the square root of 17. It's an irrational number in the denominator. We want to rationalize the denominator, which means make the denominator to be a rational number. We multiply by 1, but this one is the square root of 17, divides itself. But then this square root of 17 has to apply to both terms, to negative 3 and to negative radical 2. So the denominator now, we have 3 times 17. Because the square root of 17 multiplied by itself becomes 17. Then we distribute square root of 17 to negative 3. We get a negative 3 square root of 17. Then minus, because the negative square root 2 is a prime, 17 is a prime, cannot be simplified, so I just multiply them. So I get square root of 34. And the denominator we can multiply. 3 times 17, that's 51. So 51 in the denominator, that's our answer. The numerator is negative 3 square root of 17 minus square root of 34, then divided by 51. Now let's see 8. 8 is very similar to 7. So we know square root of 8. Remember square root of 8 is a 2 radical 2, right? So instead of multiplying square root of 8 in the denominator, we change it to be 4 radical 2. Because square root of 8 is 2 radical 2. Then 2 times 2 is 4 radical 2. So 2 radical 8 is 4 radical 2. So we just have to multiply square root of 2 instead of multiplying square root of 8. Right? In the numerator and in the denominator. These are 2 terms. So when we multiply something, we give a parenthesis. Then the denominator becomes square root 2 times square root 2, that's 2. 2 times 4, that's 8. So denominator, we have 8. The numerator actually, you know what? We can keep them in a factored form. We can just write as square root of 2 times square root of 3 plus 3 radical 5. Because mathematics, we like a factored form. Unless the question says, okay, expand them. Then we multiply those two. That would be square root of 6. Right? Then we multiply those two. That would be 3 square root of 10. Otherwise, if it does not ask us to expand them, we can keep it as a factor form and both positive. So the answer for 8 is square root of 6 plus 3 square root of 10 divided by 8. Okay, so the denominator for those ones is just a single term. Now let's see, the denominator has 2 terms. Right? Now what's the difference? The denominator will have 2 terms now. For 9 and 10, the numerator is just 1 term. Right? But the denominator has 2 terms of -1, negative square root 5. How do we get rid of this radical sign? If we only multiply by square root of 5, it won't work anymore, right? Because if we only multiply by square root 5, -1 times square root 5, we still have square root 5 in the denominator. So how do we get rid of this? Remember last time I was talking about we have this a plus b squared, difference of 2 squares, times a minus b equals to a squared minus b squared. But if we have a radical form, we have a radical a plus radical b times radical a minus radical b. That just equals a minus b. You see, this is a bridge in between of radical numbers to irrational numbers to rational numbers. We just use the difference of 2 squares, right? So in this case, we have -1 minus square root of 5, right? If we want to get rid of this negative sign, we can do this. We can multiply by -1, then change this to be positive, right? So now the numerator is negative. Or we can put the negative sign up front, like that. Because we don't like to deal with too many negative signs when we do the multiplication. So now we have 1 plus radical 5, right? So we have this form. Well, 1 you can think as square root of 1. 1 square root of 1, just 1. So we have this form. Square root of a plus square root of b. So because square root of 5 is bigger than 1, so what do? We want to think square root of 5 as the square root of 8. So we want to multiply by its conjugates. We call a plus b, a minus b are conjugates, or square root of a plus square root of b, and square root of a minus square root of b. We call that conjugates. The conjugates. So we want to multiply its conjugate. What is its conjugate? We have square a plus square root of form. So we want to multiply by, because square root 5 is bigger than 1, so I'm going to write square root 5 up front, -1. As 1 plus square root 5, we could think as square root 5 plus 1, all right? We multiply by its conjugate. We do the same thing for the numerator. So basically, in that case, we only multiply by 1. Right? Something divides itself into 1. Excuse me. Now we don't have to do the calculation for the denominator. Just by difference of two squares. That's a minus b. That's 5 minus 1, which is 4. Right? And the numerator will have square root of 3 times square root of 5, which is square root of 15. The square root of 3 times negative 1, that's just negative square root of 3. So our answer for 9 is just square root of 15 minus square root of 3 divided by 4. Now let's see 10. We have a plus square root of b form. So we want to multiply by its conjugates. Its conjugates is 5 minus square root of 2. You probably will think, okay, that's not a square root of 5, right? That's 5. That's fine, right? That's fine. So we know one of them square root of a square root of b. One of them could be just a rational number. Okay, the bottom, what do we have? I have 5 squared, which is 25, minus square root of 2 squared, which is a 2. We simplify this, we get 23. So the denominator is 23. Or what's the numerator? The numerator will have 5, square root of 5 times 5. That's 5 radical 5. It's super difficult to write on this chart. Okay, then minus a negative square root of 2 times square root of 5. That's a minus square root of 10. And that's it. That's the answer for 10. 5 radical 5 minus radical 10 divided by 23. Let's see, 11 and 12. Yeah, those are last two. So this is different from before. What's the difference? The difference is we have 2 terms in the numerator, we have 2 terms in the denominator. Right? Let's put the negative sign in the denominator up front. Then we don't have to deal with it. So now let's multiply by its conjugate. Square root of 5, again, is bigger than 2. So I'm going to write square root of 5 up front because I don't want to deal with the negative numbers. Because it's 2 plus square root of 5 is the same as square root of 5 plus 2. But when I do minus, it's different. Okay. Then right away, the denominator gives us square root of 5 squared, which is 5, minus 2 squared, which is minus 4. Oh, the denominator is just 1. We don't really need the denominator, right? So this equals to just the numerator. We have to multiply the numerator with the square root of 5 minus 2 as well. Now we have to perform the smile. Remember the smile? 2 times square root of 5, negative 3 times 2. Then multiply these 2, multiply these 2, right? 2 times radical 5, that's just radical 5. Let me just write here. So 2 radical 5. Then negative radical 3 times negative 2 become positive. That's a 2 radical 3. Then the bottom one, we have negative radical 3 times radical 5. That's minus square root of 15. Then 2 times negative 2, that's negative 4. And that's it. The denominator is 1. I don't bother to write it. So the answer for 11 is 2 radical 5 plus 2 radical 3 minus radical 15 minus 4. Okay, why don't you practice 12 on your own? All right. I would suggest you to change this to be you multiply negative sign in the numerator, in the denominator, you basically multiply by positive 1, right? So you give a -1 to the numerator and -1 to the denominator. In that case, you change this one to be positive, you change this one to be positive, then you change this one to be negative. So this becomes 4 minus radical 3 divided by 1 plus 2 radical 5. Then you want to think of this denominator as a 2 radical 5 plus 1. You want to multiply by its conjugates, which is 2 radical 5 minus 1. Okay, do that. You can do it. Okay. So that's 2. So I think that's the end of dealing with radical numbers.